Okay, so let's just forget everything you think you know about math. I'm serious. Because today, we are going to unlock the secret power of mathematical thinking. And I promise you, this has nothing to do with memorizing complicated formulas. It's all about a powerful new way of looking at the world.
So is math just memorizing formulas? I mean, for a lot of us, that's what school felt like, right? Just endless pages of drills. But the real answer? Absolutely not. True mathematical thinking is this amazing framework for seeing the world with just incredible clarity. And here's the best part. It's a skill that anyone, and I mean anyone, can build. So here's what we're going to cover today. First, we'll go beyond the numbers to redefine this whole idea. Then we'll get into the core principles. After that, we'll build your thinking toolkit, see where the stuff pops up in the real world, and finally, talk about how you can actually get better at it. All right, let's dive right in. Section 1, Beyond the Numbers. This is all about shifting our perspective, moving away from just crunching numbers and toward real, genuine understanding.
Okay, so what is mathematical thinking? Well, it's not a subject you learn in school. It's more like a new pair of glasses you put on to see the world. It's a way of approaching problems with logic, with a bit of creativity, and with this incredible ability to zoom out and see the big picture. To see the forest for the trees. It is, more than anything else, a really powerful mindset.
Okay, on to Section 2, the core principles. So now that we kind of have a feel for this mindset, let's break it down into its most important foundational parts. First up, we've got abstraction. Now, this is a huge one. It's the skill of basically zooming out, of seeing the hidden skeleton of a problem. It's about ignoring all the noise and the fluff and just focusing on what really matters. So check this out. You've got a rectangle and a parallelogram. They look pretty different, right? But using abstraction, we just ignore that slant on the parallelogram. And what do we see? They both share the exact same essential property. Their area is just base times height. That, right there, is abstraction in action, finding that simple truth that connects things. All right, so if abstraction helps us see the problem, think of logical reasoning as the engine that actually gets us to the solution. It's all about building a solid step-by-step case, kind of like a lawyer, where every single point follows logically from the one before it, all based on stuff we already know is true. And this reasoning comes in two main flavors. You've got deductive reasoning. That's kind of like Sherlock Holmes, starting with a general rule to find a specific answer. And then you have inductive reasoning, which is more like a scientist, looking at a bunch of specific examples to come up with a big general theory. Next up, principle number 3, generalization. This is that amazing aha moment. The one when you spot a pattern in one specific place and you think, hang on a second, does this work everywhere? It's about taking one little spark of an idea and seeing if it can light up a much bigger area. Okay, you have to see this. It's so cool. Look at the odd numbers. The first one is 1. That's 1 squared. Now add the next one. 1 plus 3 is 4. Hey, that's 2 squared. Let's do one more. 1 plus 3 plus 5 is 9. That's 3 squared. See the pattern? From just a few examples, we can generalize this beautiful rule. The sum of the first n odd numbers is always going to be n squared. Amazing, right? And all of this leads us to the gold standard, the absolute bedrock of mathematics: proof. Look, a proof isn't just a good idea or a strong feeling. It is a completely airtight, rigorous, no doubt about it argument that something is true. It wipes away all the ambiguity and just leaves you with pure certainty. Okay, Section 3, your thinking toolkit. So we've talked about the big ideas, the core principles. Now let's get practical. Let's build a toolkit of essential skills you can actually start using like today. So what's in this toolkit? Well, you've got the big ones, of course. Problem solving, pattern recognition. But there's also stuff like representation, which is just a fancy way of saying you can show an idea in different ways, like with a graph or an equation. And then there's critical thinking, which is your built-in lie detector for spotting bad arguments. Let's zoom in on problem solving, because it's a huge part of this. There's a simple 4-step approach that works for pretty much anything. 1, you gotta really understand the problem. No skimming. 2, make a plan. 3, do the plan. And 4, and this is the one everybody skips, but it's the most important, look back. Reflect on what you did. Did it actually work? Was there a better way? That last step, that's where the magic happens. That's where you really learn. Moving on to Section 4, math in the real world. Okay, so we've got all these cool principles and skills, but is this just abstract stuff? Where does it actually show up in our lives? Let's bridge that gap right now. The short answer? It's everywhere. I mean, literally everywhere. Scientists use it to figure out how the universe works. Engineers use it to build bridges that don't fall down. It is the absolute backbone of computer science. We're talking everything from the apps on your phone to the security that keeps your info safe. And yeah, you use it all the time, maybe without even realizing it, when you're making a budget, planning a vacation, or just trying to make a smart decision.
All right, final section, how to get better. So now you see what this is all about and why it's so incredibly useful. Let's talk about how you can actually level up these skills. And let me be clear, this is not some gift you're born with. It is 100% a skill you can practice and improve.
So, you ready to sharpen your thinking? Here's your game plan. First, just practice solving problems. Do puzzles, brain teasers, whatever you can find. And don't get stuck in a rut. Try out different ways to solve things. Super important, always think about your solution afterward. And finally, talk to people about it. Getting feedback and just kicking ideas around with others, that's one of the fastest ways to get better. It's this constant loop of doing, thinking, and sharing.
So, I want to leave you with this one thought. Now that you know that mathematical thinking isn't about numbers, but it's really about finding clarity, using logic and structure to solve problems, what's one complex problem, maybe at your job, in your own life, or just something out there in the world that you're going to start to see in a whole new light?